Okay, so let's go ahead and solve for this one. So we're looking for velocity and centripetal acceleration. All right, and it gives us the angular velocity, which is 300 revolutions per minute. But that's not in standard units, so let's go ahead and switch that first. So omega is 300 revolutions per minute. And we need standard units. So 1 revolution is 2 pi radians. So we could go ahead and change this out for 2 pi radians, because 2 pi radians, again, is 1 revolution. And then we know there's 60 seconds in a minute, so this is not going to be so bad. So that's 300 times 2 pi radians, all divided by 60 seconds. All right, now I'm going to go ahead and multiply that out with my calculator. So we get 300 times 6.28, and we get 1,884. All right, and then divide it by 60. Okay, so we get radians every 60 seconds. All right, so I took 1884 divided by 60, and I got 31.4 radians per second. Okay, so now that we've converted the units, we can go ahead and solve. So let's go ahead and take all this, put it somewhere else. Okay, and what we want to solve for now is either acceleration or velocity. And I think the easiest one right now is going to be velocity. So let's go ahead and do that one first. So V equals R omega. So the velocity is going to be the radius. And it looks like each helicopter blade is 4 meters. So the radius is 4 meters. And then omega, we already know that's 31.4. So 4 times 31.4, and I get 125.6. And that should be in meters per second. All right, next one. So we're looking for acceleration. So acceleration should be v squared over r. So v squared over r. We have v. We just found it. All right, we found it right here. So let's do it. So 125.6 squared, all divided by r, which is 4. All right, I'm gonna sort that out with my calculator. And I get 3,900, about 3,940. And that should be in meters per second squared, because again, everything's in standard units. So what we get out is standard units. So I think part B, we can answer part B now, why not? Compare the linear speed of the edge of the helicopter blade with the speed of sound, which is 340 meters per second. So it's not quite the speed of sound, right? Because the speed of sound looks like it's 340, and this is 125.6 is the speed of the helicopter blade.